So some of you heard a little bit of an introduction to some of the aspects of this story yesterday, and I'm going to show one other example of a historical scam in Australia today. That's one that we have uncovered. That's related to my story yesterday, some of the same players. So Joseph Pawsey, maybe you'd have to say it's a coincidence that he has a Canadian connection, but when he went to Cambridge, his roommate, his classmate, was from the University of Saskatchewan. This changed Joe's life because Joe ended up marrying his friend's sister. I'll explain that story. He married Lenore Nickel from Battleford, Saskatchewan, and that changed Joe's life. And hence, his connection started in 1940, 1941, and I'll show that. Let's see, what am I doing wrong, Tim?
Oh, that's my fault. I forgot to put the little dot.
Oh, okay.
Here we go. Sorry about that.
Okay, good. Thank you. Okay. So the new material, you heard about this yesterday. This is part of the book that we're writing. Ron Eakers and Claire Hooker are my co-authors on the Pawsey book. It's probably half done now. And just to remind you, in the continuation of answering Phil's question yesterday, probably the hidden archive that I talked about yesterday in Sally Atkinson's house, it's probably the rationale was an attempt to protect the legacy of Bowen. Another part of the new archive that I didn't talk about yesterday is the incredible Pawsey family archive. They didn't throw away anything. Every letter that Joe Pawsey wrote to his mother back in Victoria between 1931 and 1939 was saved. We found those letters 2 years ago, and Joe's daughter-in-law, Elizabeth Pawsey, has transcribed them, which is good for me in two respects. Joe's handwriting is not quite as bad as mine. It's better than Woody's. But, and now it's a Word file, and I can search for keywords in it. And I spend a lot of time when I'm in Sydney now at Hastings Pawsey's house in French's Forest, going through this mountain of archive. And he now has spreadsheets. It's all organized. It's an incredible achievement. And the volume of the letters that we found is probably like a third of a cubic meter. It's incredible. And thanks to Bob Hayward, who has been my advisor on many aspects. And I know if I have a question, I ask Bob sometime on the phone, sometime by email, and he answers. So summary of the topics: his life, his tragic death at age 54, years in Cambridge in the UK, the fact that he worked on early television was incredibly important for what he was going to do a few years later. Because as Australia started World War II, the same time Canada did, in September 1939, Joe was recalled to Australia. He had been working for EMI for about 5 years, and his role in the Australian radar was decisive. And I'll explain that. And that explains his trip to Canada in 1941, which was the beginning of his connections with many of the major players who became very important in Canadian radio astronomy from the World War II connection. He also had frequent visits to Canada, 47, 48, 57, 58, and the end of his life. So I'm going to spend about a small fraction of the time quickly going through his life, because that's very important to explain things. Also, I'm frequently asked about the book projects that we have, we and my collaborators. One is finished, The Four Pillars of Radio Astronomy. It's a book by Bob Frater, myself, and Harry Wendt. It's based on the biographical memoirs that we wrote for the Royal Society for Mills and Wall, and also for the Australian Academy of Science for Christensen and Bracewell. From the Sun to the Cosmos is the big book about Pawsey. As I've said, my co-authors, and I talked about Claire Hooker, the Australian-Canadian historian of science, is so important, and Ron Eakers, of course, as many of you know. And I just spent a month in Australia, and Ron decided that the only way that you can get anything done with him, because he's so busy, is you leave Sydney and you go to a nearby hotel in the Blue Mountains, and we stayed there for a month, and I had Ron's attention 24/7, which I've never had before in the last 40 years of collaboration with him. The final book I've explained a few is also finished now. This was a collaboration that really started with John Baldwin and Radhakrishnan, and we have collected the correspondence from the Radhakrishnan, Dave Morris, and Dan Harris sailing voyage of a year and a half between 1964 to 65 from Great Yarmouth in Britain across the Atlantic. Dan Harris got off and took a job at Arecibo, and then they went on to Australia. And we have then now collected the correspondence between Martin Rall and Radhakrishnan during that period, with lots of collaboration from Alison Rall Bird, who many of you know, and I've gotten to know extremely well. And again, it's very important because Alison can read the handwriting of her mother and father as we've done this, and this is all transcribed, and as I said, this is going to be a private publication of a couple of hundred copies. Pawsey was born 1908 in a very meager circumstances, a small farm in the western districts of Victoria. Only child, the first person in his family to go to university. He was homeschooled. And the key to his success in life is clearly his mother was ambitious and very well educated. And you can tell that she played a major role in Joe Pawsey's success. And he gives her credit through the years. We have two wonderful letters written after his birthday, which was in May, written 20 and 30 years later, giving her credit for his success in life. He went to the University of Melbourne. You couldn't get a PhD in Australia in the 1930s, of course. You had to go to Britain. And like a lot of other Australians that became very famous, the turning point in his life was the award of an 1851 exhibition scholarship to the University of Cambridge, following in the footsteps of someone else from a nearby country, New Zealand, Ernest Rutherford, but many other famous scientists. And he started working with Jack Radcliffe on the ionosphere. There had been a lot of discussion that he would go to London to work for Appleton, but he decided to work with Radcliffe, which was absolutely key to his success, as you'll see. And Jack Radcliffe was only about 5 or 6 years older than Joe, a very young man at this point. So, the Cavendish Laboratory, 1932. This is an impressive cohort. You're going to recognize a lot of people here. This is the class photo of 1932. There are two women here, which I know about. I don't have time. Look who's there. In the front, Ernest Rutherford, and he's only got 5 years to go. He died very early in his life in 1937, tragically. J.J. Thomson was still there, and look on the front row, you can see on the extreme left is Radcliffe as a young man. Next to him is Kapitsa and Chadwick. There are lots of Nobel Prizes here. Look at the back row. There's Joe, usually the tallest guy there, 189 centimeters, so it's always easy to find him in a... And here is a person that's going to become very famous. This is Ted Nickel from the University of Saskatchewan, also an 1851 exhibition scholar who became very well known in RCA laboratories in New Jersey later on. Two very famous Australians here, young in their careers, Harry Massey and Sir Mark Oliphant. Sir Mark Oliphant, of course, is going to become a major player in this story because it was his group that developed the or perfected, as we heard correctly yesterday, the magnetron at the University of Birmingham. A couple of years later, Oliphant played a major role. In fact, Oliphant became so afraid about the survival of Australia in 1942 that he came to Australia under great difficulty in 1942 for 8 months in order to start magnetron production in Australia, which did happen. The University of Melbourne was building L-band magnetrons a couple of years later, thanks to Oliphant's visit. Oliphant, of course, came back to Australia in the early 1950s as the ANU was founded and became very important in the stimulation of astronomy in Australia, such as bringing Bart Bach to the ANU in 1957. So it just goes on, and you can see lots of other. There's Cockcroft, a member of the Tizard mission. Blackett, who's going to play a major role in starting radio astronomy at the University of Manchester, of course. It goes on, and there's Wilson there, et cetera, many Nobel Prizes. And there's a New Zealand scientist there, Alexander. And I would be interested if any of you, I suspect there are more Canadians in this picture than I know about, but I know only Ted Nickel, but it would be interesting to know. Okay, quickly now, let's go through his career. After this remarkable, I'll come back later to a little bit of the time in Cambridge. He worked at EMI research labs for 5 years. Early television. Fortunately for the radar research, he was working on the antenna. He was making great strides on making a workable antenna at 40 megahertz, a very high frequency in the 1930s. There was a prototype television. Of course, and the prototype television was very far advanced in Britain compared to the US in the 1930s. But in 1939, of course, all work stopped immediately with television for research for obvious reasons. But this was very important because by this point, Joe Pawsey understood how VHF antennas worked, and he invented the Pawsey stub. Now, any of you who are radio amateurs know what a Pawsey stub is. I remember when my son was in high school in the 1980s, he was a ham radio operator. I was not, but he had me out doing electronics for him, which was a bit hopeless because I could hardly solder anything. And he told me to make a Pawsey stub. So I found one in a book, and we made it, of course, and we had it on his 20 megahertz antenna, like every ham radio. And Pawsey stubs are so well known now that you'll find them in all ham radio books. And it's an eponymous word, and it's written with lowercase, and sometimes Pawsey and stub are not separated. He returned in 1940. They went on a ship. Already the war was on. It was quite an adventuresome trip. They were zigzagging across the Mediterranean, across the Indian Ocean, with a passenger liner worried to death, and everyone. Stuart Pawsey was 6 months old, and he says he still has the dog tag because they were afraid if they were in the lifeboats, they couldn't find out who his parents were. So he was always wearing, as a 6-month-old baby, his identification. They get back to Australia, immediately start working. There's a long story of how Australian radar developed. The Australians, like everyone in the Far East, had the wrong strategy as the war began because they thought they had to protect themselves against invasion from ships. This was not to occur. The Americans made this mistake. Pearl Harbor showed the fallacy of this. It was the aircraft carrier was the weapon that was going to decide things in the Pacific. The Australians found this out quickly in 1942 as 3 Australian states began to be attacked by the Japanese. Northern Territory, of course, February 1942, a terrible, devastating attack that had lots of consequences in Australia. The same ships that had been at Pearl Harbor were there, the same Japanese ships. Immediately, of course, it was realized by the military, first the civilian folks in the CSIRO, and then later the Australian Air Force realized that the important thing was not shore defense, but aircraft warning. The biggest achievement of the Australian production in World War II was the radar that was built by Joe Pawsey and his group called the LWAW, Lightweight Aircraft Warning. It's a great success story, and we have a lot in our book about this. And if you're ever in Canberra, go to the National War Memorial. There is a fantastic exhibit has a real LWAW radar in it, and I've spent a lot of time there. I'm so well known there that the curators see me coming and they say, "Oh no, it's him again." So the biggest achievement very soon in 1940 was a TR switch, transmit receive. Because as you know, the problem with a radar is that you send out a signal, a very strong signal with many watts, and you get back a signal that's 10 to the minus 14 watts, so you need a dynamic range of 10 to the 19. The receive signal typically from an aircraft at 100 miles is around about 10 to the 19. So it's a big problem to use the same aerial for the transmit and receive, but it's very important. The early radars in Britain, the chain home, in fact, had separate antennas for transmit and receive. And this was not going to work for aircraft warning because these radars had to be taken around and they had to be semi-portable. Joe Pawsey and Harry Manette invented it, and it was a big achievement. This was shown by several people. In fact, I think we should say this is not an aircraft warning radar. This is a shore defense. It was used as aircraft warning. And early radio astronomy was done with this. The detection of the first fringes in radio astronomy was done with this particular shore defense, and the height of the cliff here is about 80 meters. And you can tell it's the war zone because these ships are waiting to get into Sydney Harbor. The reason they're waiting is there's a submarine net that was open once a day. And as the Australians know, there were a couple of Japanese submarines did get into Sydney Harbor. We're trying to sink the USS Chicago. In fact, they sunk one of the Manly ferries instead. First, interferometry, I don't have a lot. I should mention also, Jasper was talking about the pioneering work that Fred Hoyle did. This work was done completely independent in Australia by John Jaeger. They had seen fringes from aircraft because it was a Lloyd's mirror. They knew about Lloyd's mirror, and they worked out all the mathematics of the Lloyd's mirror and the way to determine the elevation of the incoming aircraft, because this radar typically was only good in order to determine the range and the bearing of the incoming aircraft. The height was difficult. So they knew all about this, Lloyd's mirror. When Ruby Payne Scott was observing on the 26th of January, 1947, and I dare say the only handful of us in here that know about Australia know the significance of that day. It's Australia Day. Ruby was observing that day. She was getting ready to observe the sun. They had already detected type 1 bursts a few months earlier. She was pointing at the azimuth. 15 minutes before sunrise, she started seeing fringes. She understood this. Radio refraction is twice optical refraction. The radio sun rises 10, 15 minutes before sunrise. She started seeing these huge fringes. Fortunately, she and Joe Pawsey had worked out how to calibrate radio telescopes. They knew all about antenna temperature, brightness temperature, etc. And she knew how to interpret the fringe spacing in terms of angular size. And she immediately realized that the brightness temperature that she was observing from this huge solar type 1 storms associated with the big sunspot that had just occurred in January 1947 implied the brightness temperature of 10 to the 9 Kelvin. It was not thermal. And she told her son, Peter Hall, the famous mathematician who died earlier this year, her incredible thrill to see these huge fringes at sunrise. She knew what it meant. She knew she was observing something that was not associated with the 30 arc minute size of the optical sun. The other thing, of course, she noticed that day was that the intensity of the radiation could change by 10 to the 8th Janskys in a second. So this was something new. This was not the sun that the optical astronomers knew about. The other thing they realized later on as they wrote this paper up, it was published in the Proceedings of the Royal Society, is they said, oh, by the way, the fringe visibility that we observe means that we're observing one Fourier component of the brightness temperature. In principle, we could put this back together and make at least a one-dimensional image of what the real sun looked like. So this is aperture synthesis, 1947. And the reason Ruby and Joe could do this is that they understood Fourier transforms. They understood Laplace transforms because they had been building radar with impulsive. And in fact, I have found Joe's master's thesis from the early 30s in which Fourier's theorem is described in great detail. So there was nothing new. So it's no wonder that Joe's student and acolyte, Braun Bracewell, became such an authority on the Fourier transforms. Okay, enough on this, quickly. So the real success, I think you have to say, of Pawsey in these early years is the people that he recruited. He had a fantastic gift for picking clever people, and he said this. Look at the key people he hired: Ruby, Lindsay McCready, Bernie Mills, John Bolton, Paul Wall, Frank Kerr, Christensen, Swarup, Stanley, Bracewell, just goes on and on. And it's interesting, I won't have time to go into this, in the late 1950s, early 60s, Joe Pawsey had picked Bernie Mills to be his successor, which is very striking. And in fact, Bernie Mills died on Anzac Day in 2011, and a couple of weeks before he died, I was talking to him via email through his wife about this whole succession story. Here's a wonderful story, a picture that I located a couple of years ago. You see, there's Christensen. Looks like he's pretending he's fishing in the Nepean River. This is Paul Wall looking on slightly askance at what Chris is doing, and this is Bernie laughing, I suspect. And here they're actually looking for a site for the GRT, the Giant Radio Telescope, the 64-meter telescope. And this place is in the suburbs of Sydney. This would have been an incredibly poor choice for the Parkes telescope. They didn't go there. Okay, here is a recreation of history. I had to show you this because it's related to the archival distortions. Some of you may have seen a movie in which it shows Taffy Bowen on the right driving in this peg that's going to mark the location of the GRT. And this is supposedly happening in about 1958. This is a scam because I found this picture on the left in Bernie Mills' photo archive from 1958. This picture, of course, was not in the radio physics archive, the one on the left. And look, there's Bernie with a pathetic little hammer driving a... And there's Chris looking on the right. You see Chris? This man there is the famous man whose name is Australia Home. His first name is Australia, called Austie for short. He was the owner. This picture, it's a long story how we figured this out. This picture was made 1 week before the inauguration of the Parkes Radio Telescope on the 30th of October, 1961. They had to be very careful because if they'd shown it correctly, you would have seen the completed telescope. So the reason we know this is one of the colleagues there has been able to identify where this was. This was about 100 meters away from the GRT, and there was an eyewitness that we knew that saw it. And we went home and told, he was one of the farm laborers, and said, what in the world's going on? The telescope's finished, and Bowen and a film crew are over there making this movie. And it's even worse because Lindsay McCready, I think you can see he looks slightly embarrassed. He should be. And he made the film on 2 days, and his clothes are different. So it's a poor scam. I just had to show you this because we included this in the biographical memoir of the Royal Society with Mills, because Mills was so proud that he's the real person that drove the stake. And it's, of course, the irony is that by the time the Parkes telescope came along, Mills had left radio physics under a fair amount of acrimonious experience and had joined the University of Sydney. Okay. The year of the schism, I won't go through this, 1960. Two prominent people left, Mills and Christensen, and it had to do, of course, would they build the Supercross, as it was called then, later on called the Malonglo Cross. Bernie Mills, and as I said, I spent many hours talking to Bernie Mills in the last years of his life. John Bolton was brought back to really usurp Pawsey, so that it was at this point that Pawsey left and was on his way to NREO. I will go through. The Parkes telescope opened. This is Joe Pawsey's picture. You can see it's an old picture. Those of you who know Parkes, look, there are no trees there. And now you go along that alley, it's full of trees. An amazing creation. There are connections, of course, with ARO, as you know. Freeman Fox is the common, and Mike Jeffrey. Some of you know that name. I may have time to talk about him, who had been the Freeman Fox engineer that played such a key role at both the Parkes telescope and later on at Algonquin. Okay, very quickly, the end of Pawsey's life, he comes to NREO. He's going to take over. He had been recruited by Isadora Robbie, the president of Associated Universities. He comes to Green Bank. Within a couple of days, his terrible brain tumor leads to a paralysis. We have eyewitnesses. A lot of Frank Drake has written about this. Campbell Wade and Doug and Dave Hogg have witnessed this, and I've talked recently again to both Campbell Wade and Dave Hogg, and they know about. They thought Joe Pawsey had had a stroke, but in fact he had a glioblastoma multiforme, the worst aggressive type of brain cancer. It's amazing that we have pictures. You can see he's already paralyzed here. His left hand, he could hardly walk. His left hand is paralyzed. He was looked after by his Canadian brother-in-law and his Canadian sister-in-law. That's Ted Nickel there. I'll come back to Ted in a minute. Here he is after the operation, a very long operation, which really only succeeded in giving probably Pawsey an extra 6 months of life. You look how frail he is. But when he came back to Sydney after this, he had about 4 or 5 months. He was very active. He wrote his plan for NREO in the future. And thanks to Ellen Boughton's wonderful archive, we found this some years ago. And it's remarkable to see the plans that Joe Pawsey had for NREO. And it's interesting to us that one of the key aspects of his plan was to bring 2 people in from the outside that understood interferometry, because he said it is remarkable how few Americans understand interferometry in radio astronomy, which was a true statement. So he was going to hire Peter Scheuer, whom he knew well because Peter was on a sabbatical in Sydney at this time. And he was going to hire Bill Erickson, who was in Holland working on the Benelux Cross. Neither one of those worked, of course, because Joe was in the process of dying, and he was to die in November. But he finished this report. He also edited a special edition of the Proceedings of the Institute of Radio Engineers Australia on radio astronomy, and to within a month of the end of his life. And the last person outside the family that was in Joe's room before he died 2 days later was Dave Hession and Gerald Tape. Gerald Tape had become the president of AUI by this point. Robbie had relinquished the job a few months earlier. So, at age 54, he was dead. Incredible tragedy for the family. Amazing tragedy for NREO, and I suspect it probably also had some influence on the evolution, and I may talk about that at the end of relations between the U.S. and Canadian radio astronomy, because obviously Joe would have been very attuned because he knew everyone in Ottawa at this point. He had been there many times. So let's quickly now, that I don't have much time, 1931 to 35, but this is a key point of Joe's life. He was the ultimate networker. I think he realized, like, of course, naturally it was obvious, that he needed to meet people in his discipline, related disciplines, and he did this his whole life, and this explains a lot, I think, of the success of radio astronomy in the early years, because Joe and Bowen got to know people outside of Australia quickly after the war as they began. And a lot of this was based on World War II, of course, and their connections. Fantastic piece of luck. You always got to be ready for accept good luck when you're working on archives. And one day, Doug Johnstone was in Socorro giving a colloquium, and we were talking about something, and he said, "Oh, my relatives, the Pawseys, in Sydney." So I said, "What?" So you can see what happened. The next day, I was on the telephone with Doug's mother in Ontario. And you can see one thing led to another, and after a while, I was talking to her, his cousin in New Jersey, and I discovered the Nickel family for the first time in their incredible archive. And after a while, I had Ted Nickel's diary from 1931 to 1935, which has a lot of material about Joe in it. So this just goes on and on. And the fact that the Nickel family ended up looking after Joe at the end of his life is an incredible service. And of course, Ted and Kate Nickel are now dead, but their children I know well, and they've been incredibly helpful because they saw Joe when they were young people, and et cetera. So there at Cambridge, Joe was very clear to his parents. He said, my friends probably, I think they should be from the Dominion. He said, sometimes if I meet an Englishman, I'm not sure, is the Englishman happy to see you or is they happy to see you leave? But he said, so my friends, they're going to be Australians, New Zealanders, South Africans, and Canadians. Well, because Ted was a Canadian, it turned out that most of Joe's friends at Cambridge were Canadians. And here they are. On the left, you see the tall Joe, and that's his soon-to-be wife, Lenore, who was visiting. And that's his daughter-in-law, Kate Neatby, who was born in Earl Grey, Saskatchewan. Had been the departmental secretary of the University of Saskatchewan and Saskatoon in the 1930s. There's Joe on his motorcycle. Ted had a motorcycle. They went around Europe. And sometimes they were spending, 3 shillings a day. They were pretty proud of their expense account. And they experienced some amazing things in Europe. They have pictures of Nazi stormtroopers in Cologne. Joe and Bill Henderson, another Canadian I'm going to talk about in a minute, drove through the outskirts of Nuremberg in 1934 when there were hundreds of thousands of people in the street, including Nazi banners, et cetera. They have pictures of this. So they witnessed the oncoming, obviously the events in Germany, which were leading rapidly to World War II. There's Joe standing on some place in the Alps. Now, quickly, Joe's letters, they are fantastic. Sometimes that's where he admits that his girlfriends are typically Canadian, or sometimes they're New Zealander. And he's got quite a network of friends. He writes lots of letters to his parents, and they discuss philosophy. His philosophy of science is explained one place. It's just an incredible way he talks about empiricism, and is it induction or deduction, et cetera. It just goes on and on. There's a lot about communism versus socialism versus democracy, so that's a very eclectic. And sometimes he starts explaining about the ionosphere. So he draws a picture to his mother. He shows an interferometer. It only was recently that I realized that you see there's the transmitter on the left. This is his little hand drawing in the letter, transmitter. There's the ground wave, and this is the receiver that's, say, at Cambridge. And it's about 80 kilometers from the BBC transmitter somewhere in London. There's a downcoming wave coming from the Heaviside layer. They were using the word ionosphere. And this, of course, you get fringes, and that's a single dish interferometer, of course, because you can change the phases of the fringes here as they did. This was a transmitter, actually not at the BBC, but at one of the radar, at Slough, in which they changed the frequency and the phases of the fringes changes as they should. This is a single dish interferometer, just like the Seacliff interferometer. And what he was really doing in the purpose of his thesis was to measure with spaced receivers. He would have two receivers at Cambridge spaced 1 meter, 10 meters, 30 kilometers. And it was good he had a motorcycle because he had to go between the two receivers over 30 kilometers in the middle of the night. And he got awfully sick of the mud in East Anglia. He said it was an advantage to do these experiments in the winter when it was frozen, because there was too much mud. And he said, oh, by the way, since I grew up on a farm, I know about mud. He said, at least the quality of the mud in these fields I'm working in is slightly easier to walk through than it is at the dairy back home. So he was measuring the deviation of the two waves. He was actually measuring the velocity in the D layer. And they were measuring velocities up there at 100 kilometers of 80 to 90 kilometers a second. These very high winds, of course, it's very common, and this was a new thing. So, quickly now let's move to Canada. The war has started. I've talked a little bit about how he was prepared for the war. So, within the first year or so, they did perfect the shore defense. But of course, looking for ships and airplanes is a completely different story, because if you're looking for the ships, they're probably 30 miles away, not 100 miles away. And you need to know the bearing ever so precisely, because they started practicing with artillery, where they were actually shooting from the coastal guns out to dummy ships in the Tasman Sea, watching the path of the shell and how close it would come to the wooden barge out in the sea. Well, this is not what you want for an airplane, but they were perfecting a radar, and they were able to, very quickly after Pearl Harbor and the Darwin disaster, they were able to perfect the aircraft warning, which was all done at 200 megahertz. That was very important because it was a simple radar. You didn't need a magnetron. You could put it together. You could throw it into the sea in boxes, and you could put it together quickly. And it was simple, and it worked in the tropics. The first American radars that were brought to the South Pacific in 1942 were hopeless. They were too heavy, and they corroded. The Australians understood corrosion. This was very important because a large portion of Australia is in the tropics, and it was wet and humid, and you had to be prepared for this. And the American radars, for instance, at the Solomon, Guadalcanal, the aircraft warning that the Americans brought was pretty useless. It was the Australian radars that worked but they realized, of course, very soon, as they wanted to go to aircraft radar, we heard this story yesterday, they wanted to go to ASV, aircraft to surface vessel, and especially AI radar, aircraft interception. You needed high frequencies, and they heard about the magnetron. So in 1941, the Tizard mission had been in Ottawa and Washington a year before, and it's very important that there were two key people there as far as we're concerned. There's Cockcroft and Taffy Bowen. Taffy Bowen is a key player, and he was in Ottawa in 1940. And as I'm sure most of you know, that Tizard, the first place he came to in North America was Ottawa, and later on went to Washington and became very closely connected with Mackenzie from NRC. So, 1941, the Australians realized they've got to get into the high-frequency radar, S-band. They say Pawsey needs to go visit the NRC, and he needs to go to the radiation laboratory in Boston to learn about these. And he goes, he gets on a flying boat. It takes forever on a flying boat from Sydney to California. The flying boat is flying at an elevation above the sea of 2,000 feet at 130 knots. That's a long way from Auckland to Honolulu. You got 40 hours of flying. And you had to wait for the flying boat. It's the Pan Am plane. So it's a big adventure as to how to get there. He had a lot of stuff with him. He was taking a lot of shore defense information, some hardware even, to Ottawa to show that the Canadians were still interested in shore defense radar. So he ends up, and unfortunately, I think a lot of what happened in Ottawa then is so classified that we don't know. I mean, it hasn't appeared, so we don't know a lot of the details. But we do know, here's his visa. He had to get a visa from the American consulate in Sydney. And then when he crossed the equator, you got one of these cheesy certificates from Pan American Airlines saying you'd cross the equator. They don't do that these days when you cross the equator, as many of us do frequently as we go to Australia. But he visits, he meets a lot of people. We do know from later on, he was at Bell Labs, and he met Fries, Jansky's boss. He met Southworth. He met Carl Jansky himself. He met Carl Jansky several times. And Carl Jansky died, was it 50 or?
1950, yeah.
1950. So at least he met Pawsey on two visits. And
is there any mention of the Jansky noise before he meets Jansky?
No.
Anywhere?
No. We only can figure out he met Jansky from letters that he wrote years later. He says, "It's nice to meet you again." He met some very key contacts in Boston, of course. He meets Isidore Rabi, the associate director of the radiation lab, who was going to become his boss, and Lade Pawsey, the big boss at the radiation lab, subsequently starting radio astronomy at Caltech when Lade Pawsey was the president of Caltech. He meets the man that those days was called Eddie Bowen. Taffy Bowen didn't become Taffy until he moved to Australia. I think maybe he thought Eddie Bowen was not dignified enough. But when you find letters from Lovell, Hanbury Brown, et cetera, anybody that knew Bowen during World War II says, "Dear Eddie." And when I talked to Graham Smith and Sir Bernard in 2007, I think, at Jodrell Bank, they kept on referring to Eddie Bowen, and I always would kind of jump like that because when I went to Sydney in 1967, our big boss was Taffy Bowen. We didn't call him Taffy, of course. And I've got to tell you, the first letter I ever got from Bowen when I showed up there, I didn't appreciate, because my name was a big problem for people in Australia. They thought that I was a hyphenated. I had a lot of prestige at first because they thought I was Miller-Goss. And I said, no, that's not right. And so I lost a lot of prestige then when I lost my hyphen. And Bowen, you could see him in the hall, and of course all the postdocs were scared to death. You know, he was a famous man, one of the inventors of radar, et cetera. And I got a letter from him, and he said, "Dear Goss," and I jumped off the page. You know, I thought, gosh, what's going on? Is he going to fire me? And of course, it was, and later on, this was certainly the Brits in Australia were having very great difficulty at this era calling people by their first names. So I can remember, as I got to know Hanbury Brown very well, he found it very difficult not to call me Goss. That's an example. Anyway, let's move right on here. He goes back. He takes 22 kilograms of correspondence because it's a way to get a secret correspondence back to Australia. They're getting ready for aircraft warning, but they have some magnetrons now in Australia, and he becomes in charge of the microwave group in Australia, and they actually eventually have a very nice small mobile naval radar at S-band working on Australian ships. and there's also an aircraft warning, because a couple of years later, the Japanese do figure out how to jam the Australian radars. Okay, now, very quickly, his Canadian friends, Bill Henderson, and incidentally, I'm sure a lot of people in this room probably know more about Bill Henderson than I do. I cannot find very much about him. He was a classmate at Cambridge, 2 years behind him. They did a trip together, Bill Henderson. He only appears in the correspondence in Australia. And of course, all of my material here is based on material I have found in the Australian archives about Canadians. He gets this nice letter from Henderson. Covington has written about the role that Henderson played on the connection with Pawsey. I'll show that in a minute. This is a letter from Bill, 1946. It's a fascinating letter. He says, I've been to, let's see, he says, we've been working on S-band radar, S-band radio astronomy of the sun, and we do daily. This is 1946. We're getting ready to start radio astronomy of the sun, and the postscript has to do with, oh, by the way, Joe, you're famous in the Canadian papers because we read about you in terms of this, of the Canadian spy scandal. Alan Nunn May. It's a long story, which I don't have time to go, but the Nunn May scandal had a big impact in Australia because of controversy as to whether the Australian scientists would support him or would be opposed to him. And the secret police in Australia, the ASIO, ended up reporting on Pawsey, and they were very proud that Pawsey said this was probably not something that we should get involved in. But it led to a lot of discussion in Australia as to what would be the response in this. But the main connection with Canada is Don McKinley. Don McKinley, I suspect Joe met him for the first time when Don was sent to Australia at the end of 1943 for a long visit. He was going to look at the problems of radar in the Southwest Pacific, talk about Canadian policy on radars, good. And he was taken to the front lines in New Guinea. They took him to the north coast of New Guinea to Milne Bay, I think, where the Australians were still fighting the Japanese in a very bloody battle, but at small, tens of thousands of troops were involved. So the fact that, and it took a lot of effort to allow, to take someone from another country to the front lines, that's interesting. Also, the Earthly General Assembly in Sydney, 1951, which we've heard about, Don McKinley was one of 3 Canadians at the conference. So there's lots of correspondence. Only picture I can find of Don McKinley, I'm sure there are many, but this is at the opening, there he is. I'm sure some of you can help me find contemporary photos of Don McKinley, and so I would like to get those for our book. Okay, now I'm not going to have time to talk about this. All through the 50s, the NRC was trying to get Pawsey to come for a year or 2 to Ottawa. It goes on and on and on. Letter after letter, Don McKinley is involved. It starts actually with Ballard. Ballard, which I think was he the vice president of NRC at this point, wrote a letter to Bowen, said, we would love to get Pawsey to come and spend a year with us. This goes, I don't have time for this. It just goes on and on, letter after letter. Joe writes, it is a great pity, 1957, that your plot about my year in Canada broke down. He's going to be in the U.S. for 7 or 8 months in 1957-58 because, in fact, Merrill Tuve and Isidore Arabi at this point were trying to recruit Pawsey to come to the U.S. to become the new director. We've only figured this out, and this was to happen a couple of years later. He's so frustrated. He never made it to Canada for a long visit. He was there many times, and he writes his mother, I should like to go and have a look at Canada, he says, in 1954. on a more leisurely basis. I think this is possible in the next year or so. Just at the moment, I should like to develop a little perspective and not personally get too much involved in detail. This never happened. Okay, the most important part of the trip, and I'm running out of time, there are two major visits to Ottawa, 1957 to 47 to 48. This was the most important networking visit of Joe's career. He comes to the US and Canada and Europe for the first time and meets real astronomers, as he would have called them. He meets Struve, he meets Minkowski, he meets Bada, he meets Oort. It just goes on and on. He makes contacts, and he gave lectures at Yerkes. He gave lectures in Ottawa, Boston. He was at Harvard, et cetera. It just goes on and on. Then he's in Europe for many months visiting the Cavendish lab, but also many visiting other places. He went to Ursi in Europe. So this was the ultimate visit for the Australians. Was a key visit. Woody has written about this in his book very effectively, of establishing contact, and it was on this trip that he invented the phrase radio astronomy. He realized that they had to become astronomers. And it was in some of his letters, it's clear that they don't know about precession, as Woody mentioned. They're learning about that rapidly. They go to Canada, they visit a lot of relatives. Here they are in Saskatchewan. There's Joe, looks a little cold. He's an Australian, but I did realize only recently, he knew how to ski already. He had been skiing in the Alps. Of course, Australians, I think in 1947, there were not many Australians that could ski, and no Australian had ever experienced weather like this. And it's interesting to read Lenore's letters from Sydney. She was going to spend the rest of her life in Sydney, having grown up in Canada, and she is always complaining about how cold Australian houses are. And I actually know that because I noticed when I went to Australia in 1967 when I met Mike and others, and Tom for the first time, how cold I was in Australia. You remember that. But it was the Canadians that complained more than we did. I noticed. I was always proud that I've complained, but it was people like Peter Shaver and maybe Jasper. I don't know. I don't remember Jasper complaining, but I remember Peter Shaver complaining about the cold. So I didn't feel too bad if the Canadians suffered more than we did. So here they are. They go. You see, it's a typical visit, right? They go to Niagara Falls, and everybody has to take a picture of an Ottawa, right? You can see it's pretty clear. And he meets Grote Reber for the first time. Here he is. This is Joe's picture. This is a very important visit. He hears about the hydrogen line. Long story. I don't have time to go to that. But Grote says, there's a line out there you guys should be working on. They come home. He visits the NRC. He appears in the Ottawa Evening Citizen on the 12th of February, 1948. And for some reason, the whole story is about cloud seeding, not about radio astronomy. But he does visit Arthur Covington, and he writes back. He's impressed, but he's slightly reserved. This is Joe's assessment of Covington, a young and inexperienced man working in relative isolation, thoroughly useful results. And this was going to change, of course, because in subsequent years, Christensen and others, of course, had very close connections with Covington. And this is where, from Woody's book, that you can see that Covington reports that Joe Pawsey talked to him, trying to get him to do the hydrogen line in 1947. And look at this. This is what Covington. I was introduced to Pawsey during one of his early visits to the radio field station by Bill Henderson. Okay, now I've got to, since I'm really running out of time, the most important part of the last few minutes has to do with Ralph Williamson. Some of you heard about Ralph Williamson. Joe Pawsey became infatuated with him, a young American theoretician that he met in Toronto in 1948. He met Frank Hogg, he met Helen Sawyer Hogg, and he met Ralph Williamson. Ralph Williamson wrote some amazing papers that appeared in the Journal of the Royal Astronomical Society of Canada, one called The Development of Microwave Astronomy. He had been at Cornell, so that's why he was using those. This is an amazing paper. I read it yet again the other day. I urge you to read this paper. This is what Pawsey says in his letter. Williamson is a young astronomer who is thoroughly interested in one subject. In fact, he's acting as a sort of promoter of such research. Present status of microwave astronomy, 1948. Please look at this. It's incredibly well written. There was so much uncertainty in 1948. How do you calibrate? What does it mean? Is things thermal, non-thermal? What is the brightness temperature? Williamson understood this. He had a PhD working with Chandrasekhar. He had grown up in Oklahoma, got a PhD in 43 or 44 with Chandrasekhar at Chicago, and there are 10 or 20 letters in the Australian archives as Joe Pawsey tries to recruit Ralph Williamson. It wasn't to work. Because Williamson knew astronomy. He understood the theory. He understood radiation transfer, which you can see is very important. And there's just quote after quote that I love, that, you know, this is some. However, it will be extremely rewarding, and that will shed entirely new light on conditions of the interstellar matter in our galaxy in order to understand the background radiation. That's pretty important. We don't have time to go through this. Ralph Williamson shows up in various pictures. A wonderful interview that Bob Hayward and I had with Vic Gazauskas in 2010. And you can see, of course, there's Ralph there. There's Helen Sawyer Hogg. This is after Frank Hogg is dead. That's Jack Hurd, I guess. Nancy Roman is in this, etc. This is Ralph's picture. Bob pointed this out to me a few days ago. This is a wonderful picture where Ralph looks like Orson Welles. And one day, one weekend, Ralph disappears, but only after he had turned down Joe. And letter after letter, Joe's trying to get him to come to Australia, even for a year. And unsuccessful, because Joe thought this was going to be a great asset to have Ralph in Sydney. He also said, I can help you predict the hydrogen line. That never happened. He disappeared one weekend. It turned out that he had found a new wife down this road, a school teacher in Richmond Hill, and he left. And Don McRae has worked about this, and Dave Hogg has told us this, and he left immediately, leaving his wife behind in Toronto. Now, Dave Hogg says he was 15 or 16 years old, and his mother was absolutely incensed. She was not happy, and Dave says Ralph became a persona non grata in their home. He was never to be discussed again. And he disappeared from astronomy, but he got a job at Los Alamos. He was an American citizen, and the rest of his life was there, and he never went to a astronomy meeting again. So, we have the class notes. He turned him down. He didn't come. Letter after letter goes on trying to recruit him. He had letters of recommendation for Gerard Cowper, etc. I don't have time. I'm going to just show a couple of pictures. 1958, this is the last thing, Tim. I'm rounding up here. Joe is in the North America again for about 6 or 7 months. As I said, he's being recruited. He was mainly in Ann Arbor, but he came for a week to Canada in the end of 1957, and he meets lots of people. But before he is there, he's at Harvard. And look who he meets one day. The 25th of November, 1957, he meets this man here, who this morning pointed out to me he had a little bit more hair in this picture. There's Kochu at Agassiz Station with Tommy Gold. On the right, who's on the left? It's a very young person, even younger than you, Coach Yu. Anyway, he's trying to get Coach Yu to come to Sydney. He only got him there on a visit, a long visit. So, okay, they take pictures there in 1957. They do a lot of things, and this is the last thing I'm going to talk about. He meets lots of people in 1957. He meets Jack Locke, he meets Norm Broughton, he meets Beals, and they talk about the White Lake Observatory, because at this point they realized that this place was going to occur, and clearly because of the emphasis was going to be on 21 centimeter H1, this was a big deal. There's no mention of ARO yet. I think that's still a little early at the end of 57. I don't have time for any of this. Last 2 slides, I promise. Now I've got to show you a connection that Woody Sullivan is to blame for. This is the Ron Bracewell radio sundial. You can see Woody there dedicating it with all the ribbons, etc., on the equinox in 2013. This is a sundial that's made out of the piers from the Bracewell telescope that have signatures on them. Look at Pawsey signed it. Lots of famous people. Art Covington is on here, etc. This is a real working sundial. Woody is a gnomon, but you see this is incredible gnomon here. And this is the Pawsey family, but Carl Jansky's daughter was there, and the Bracewell family was there, and we had a lot of fun. And this is a great tourist attraction now, and Ellen has helped a lot to do the identification of the signatures. There are 200 of the most famous scientists of the mid-20th century are there, and we have a piece of ARO. We had one of the telescopes from the Bracewell array. That's the telescope, and they had taken the feed off, which we were very upset by. We didn't have a feed, and Bob, I think, knew that Rob Stevens had some of the feeds from ARO, and we got involved with some in long, torturous barter with Rob. We had to give him an OMT, etc. It went on, but he was good-natured about it, and sure enough, it showed up. So I hope you were impressed that this is a piece of ARO that's at the VLA site now, because we do need one of the J-hook feeds, and that's it. Thank you.
Thanks so much. That's really great questions. Tom?
A note about Bowen. I don't think the name Taffy is a mark of respect.
Well, yeah, well.
You know, a label that Australians had for all Welshmen, and I can remember a nursery rhyme. Taffy was a Welshman, Taffy was a thief.
Well, only in defense of my claim, Tom, is that I've talked to Edward Bowen, is a friend of mine. I just saw him recently, and he always said that at least his dad thought this was, he liked Taffy a lot more than he did Eddie. Maybe that's I shouldn't use the word respect, but at least E.G. Bowen would prefer to be called Taffy.
Several different comments. I would disagree a little bit more about Pawsey and Fourier transform. It's really Radcliffe where if you studied under Radcliffe, you learned Fourier transforms inside out as well as the ionosphere.
I agree with that, but in his master's thesis that was done in Melbourne before he got to Cambridge, there's a
Before Cambridge.
3 pages of Fourier transform stuff, and he was talking about Fourier transform. So certainly he learned a lot more.
And you know, Ryle was Radcliffe's student. Bracewell was Radcliffe's student. Bracewell's Cambridge PhD in the early 50s was on the ionosphere. And the Radcliffe notes were just famous throughout these decades. Or this was the Bible on Fourier transforms. A second point was that Paul Weil gave me a great quote one time about the empiricism that you briefly alluded to of Joe Pawsey. He said Joe liked to say, "Suck it and see." He was always visiting the field stations around, and he wasn't taking anyone's word for it. Suck it and see.
All right.
A third point, first names in England. I was astonished also. I was interviewing someone from the Chadwell Bank Group in the post-war decade, they could not remember the first name of somebody. We just call him Smith. I don't know what his first name was. But it was obvious that was what everybody just used. They did not use the first name.
Jasper?
I can follow on from that. When I first met Sir Bernard Lovell, I was Wall. Always Wall.
Yep.
When I became a member of the visiting committee at Jodrell,
Yeah.
I became Dr. Wall. Wait on. When I became chairman of the visiting committee, I became Jasper.
All right. Yeah, looking through the records here and various interviews, I saw that people kept remembering that a major impetus for getting into radio astronomy was Pawsey's visit. But then you look back in the record, well, it really looks like Pawsey's visit was 57 or so. 55 is when the applications for grants were submitted. So really, it seems like it was Bolton who really got things going, but Pawsey's visits must have had such an impact that people remember that it was Pawsey that got things drove the observatory search.
Speaking of Bolton, I didn't mention this. In, the interview that Bob and I had with Victor in Ottawa in 2010, he said, "Oh, by the way, Bolton gave a colloquium in 1950 in Toronto." That was on an earlier visit. It was when on his world trip, John Bolton, and he has a notice. I have the notice from but Ralph Williamson was giving a radio astronomy course in Toronto, and we have the notes from that Victor took in. It's all good stuff. I mean, it's just, it's like the things that we would do now these days, and this was 1948.
But Charlie Seeger and Williamson wrote a paper,
Yeah.
which was published in Astrophysical Journal.
Correct.
That's what got me to correspond with Charlie.
This little paper by Seeger and Williamson.
Yes,
Yeah.
Seeger and Williamson.
That's right. Did you ever meet Williamson?
I didn't meet him, but I had a lot of correspondence with Charlie.
All right. This is great, but we do have to move on. I'm really sorry about that, because this is a lot of fun. So let's cover this during the coffee break.
I only got one.
Thanks for our guest.